Alright, Wildcats, we're back with another video. This one regarding the rules of exponents. So, we've got 6 rules that we're going to focus on with this video. The first one, what happens if we have x to the a times x to the b? So in other words, we're multiplying two terms, and the terms have the same base. So we see x and x. They may not have the same exponent. So right now it's just a and b. I'll do an example with some numbers in a second, but ultimately, this rule, as you're probably already familiar with, what we're going to do for our result is we're just going to add the exponents. All right, so we're just going to add a and b together. So for example, if we were to have 3 squared times 3 to the 8th, all right, we're trying to figure out what that's equal to. Well, we just add our exponents. So 2 plus 8. We know 2 plus 8 is 10, so our answer would be 3 to the 10th. And again, the idea behind it is we have 3 squared, which is 3 times 3, and then we have 8 more 3's. 1, 2, 3, 4, 5, 6, 7, 8. And they're all being multiplied together. Well, how many 3's do we have in total? 10 of them. Hence the reason why it's 3 to the 10th. All right, so if we can add exponents, then we can subtract them as well. Well, multiplication of the two terms leads to us adding the exponents, which means if we're dividing the two terms, then we'll just subtract the exponents. So x to the 8th power over x to the bth power will be x to the a minus b. Okay? So again, putting this as an example, if we have 2 to the 5th over 2 cubed, that's just going to be 2 to the 5 minus 3, or 2 squared. That's it, or 4. We know 2 squared is 4. Here's the idea behind it. 2 to the 5th, that's 5 2's. 1, 2, 3, 4, 5. That's up in our numerator. Down in the denominator, we have 2 cubed. So that's 3 more 2's. 1, 2, 3. Well, we have the same item in the numerator and the denominator. They're connected by multiplication, which means that we can start crossing them out. These 2's cross out, those cross out, those cross out, leaving us with 2 2's, or 2 squared. Hence the reason why this works out. So we add our exponents. If we have x to the a times x to the b, if we're doing x to the a divided by x to the b, we subtract them. If there's only one base, but still 2 exponents, in other words, we have an exponent to an exponent, then the result will be if we were to multiply the exponents. Okay. So for example, if we have x to the 3rd, and that's being raised to the 4th power, well, that will be simplified as x to the 12th, right? Because 3 times 4 is equal to 12. What's our proof of this? Well, we have x cubed to the 4th power, which means we're doing x cubed times x cubed times x cubed times x cubed. Right? There's 4x cubes all being multiplied together. What's x cubed? That's x times x times x. And then we've got it again a second time, and then a third time, and then a fourth time. They're all being multiplied. Guess how many x's we have total? 12. And last but not least, the most difficult one, we see that we're adding our exponents, subtracting, multiplying. If we see a radical, that's going to lead us to a rational exponent. In other words, we're going to divide our exponents here. So we're going to have x to the a over b. All right. So what's happening here is we're taking a specific root. Now, if there's no number there, then it's understood to be a 2. All right. That's known as a square root that we've been familiar with for quite some time. If there's no number here, it's understood to be 1. All right. If there's no number, then it's just x to the 1st power. So, but if there are numbers here, then we'll just use those. For example, if we have the cubed root of x squared. The cube root of x squared, well, the 2 matches with the a, and the 3 matches with the b. A goes in the numerator, b goes in the denominator. So this is equal to x to the 2/3. Okay. One more example, if we were to have the square root of x. Well, there's an unwritten 2 right there. Square root means there's a 2 right there. We don't write it, but it's there. So as we write this as a rational exponent, our denominator is going to have a 2. Our numerator is going to be the exponent of x. Again, there's nothing written there. That's understood to mean there's a 1 there. We don't write it, but it is there. So we have x to the 1/2. So that's our conversion when we're going to be dividing exponents. Now there's 2 more cases that don't involve adding, subtracting, multiplying, or dividing the exponents, and they're over here. Every exponent that I've dealt with so far has been positive. What if the exponent is equal to 0? Well, it turns out that anything to the 0 power is 1. Okay. Quick proof of this, or a quick idea behind it. Let's say that you had 10 to the first power. What's 10 to the first power equal to? 10. It's a 1 followed by 1 0. What if you had 10 cubed? 10 times 10 times 10. That's 1,000. It's a 1 followed by 1, 2, 3 zeros. So 10 cubed is a 1 followed by 3 zeros. 10 squared, it's not on the board, but 10 squared is 100. 10 times 10 is 100. That's a 1 followed by 2 zeros. 10 to the first power is a 1 followed by 1 0. So if we have 10 to the 0 power, that's a 1 followed by no zeros. 10 to the 0 is 1. In fact, anything to the 0 is 1. Lastly, we have our negative exponents. Okay, how do those work? Well, let's look at some examples first, and then we'll come up with our rule. 2 to the 0 power. We just talked about that. Anything to the 0 power is 1. 2 to the first power. That's just itself. That's 2. 2 squared. 2 times 2. That's 4. So look what happens as we move from the bottom up. Look at our exponents. 2, 1, 0. We keep subtracting 1 from our exponents. Let's look at our answers. 4, 2, 1. We cut 4 in half. We get 2. We cut 2 in half. We get 1. Now we're going to subtract another 1 from our exponents, which means that we have to cut this in half. Half of 1 is 1/2. To get our answer up here, we're going to cut a half in half. Half of a half is a quarter. Now a quarter, that 4 right there, remember 4 is really 2 squared. So even though we have 1/4, it's really 1 over 2 squared. So 2 to the negative 2 power is the same thing as 1 over 2 to the positive 2 power. 2 to the negative 1 power is the same thing as 1 over 2 to the positive 1 power. All right, if we put in one more here, 2 to the negative 3, well, that's be half of a quarter. Half of a quarter is an eighth. And that's the same thing as 1 over 2 cubed. So 2 to the negative 3 power is 2 to the positive 3 power as long as it's moved down into the denominator. That's our rule in general. If we have x to the opposite of a, we have a negative exponent, we want to get rid of that negative sign. Well, we can make our exponent positive, but it needs to move down with the base into the denominator. That's our final exponent rule right there. Again, a negative exponent can become positive as long as the entire term that belongs to the exponent is moved down into the denominator.